All right, so you've sent over some research about a sinking basin in Turkey.
Yeah.
And I got to say, my first thought was, how fascinating can a hole in the ground really be?
Right.
But knowing you, there's got to be more to this. Let's dive in.
Well, you're in for a treat with this one. It's a real head-scratcher for geologists. We're looking at the Turkish plateau, right? Which, by all accounts, should be rising. Plate tectonics, the usual stuff.
Right.
But there's this basin, smack dab in the middle of it all, the Konya Basin, and it's doing the opposite. It's sinking.
Sinking. How much are we talking here?
About 20 millimeters a year, according to this article from sinexx.de. Not a huge amount, geologically speaking, but still, it's going down, not up.
So like a slow-motion geological tug-of-war? What's going on beneath the surface to cause that?
That's the million-dollar question. And the answer seems to be something called a lithosphere drip. Imagine like a giant droplet of rock, but we're talking super dense material coming from the Earth's lithosphere.
Okay, hold on. Lithosphere, that's the Earth's crust and upper mantle, right? Yeah. The stuff we're standing on right now?
That's the one.
Doesn't sound very drippy, though.
Exactly. It's counterintuitive. I mean, we think of rock as, solid, but this research is suggesting that over millions of years, the pressure, the heat way down there, it can cause even solid rock to behave kind of like, well, a fluid.
Really? So almost like, I don't know, silly putty or something.
Kinda, yeah. And get this might not even be the first time Turkey's had a run-in with a lithosphere drip.
Oh, tell me more. What happened before?
Well, there's a study a while back that found evidence of another lithosphere drip, but this one detached millions of years ago, like 25 million. And when it detached, guess what?
What?
The land above it, it sprang up. That's right. It basically popped up like a spring. And that, they think, is how the Turkish plateau became, well, a plateau in the first place.
Wow. So one drip pushed the land up, and now we've got another one pulling it back down. Is that what they're thinking?
That's the theory. The new research suggests there's another drip forming right now, still attached to the lithosphere. So picture this massive weight just slowly pulling the land above it downwards. And that's creating that sinking basin.
That is wild. It really makes you think twice about what's going on beneath our feet. But how can scientists even study something like that? It's happening so slowly and so deep underground.
Yeah.
It's not like you can just dig a hole and have a look, right?
You're right. It's not exactly easy to observe. This is where it gets even cooler. They recreated it.
Recreated it?
Yeah, in the lab. They made a miniature model of the Earth.
Wait, a model Earth. Okay, now I'm really interested. Did they shrink down a bunch of rocks or something?
Not quite shrinking rocks, but close. They took a tank, a big one, and filled it with this gooey liquid. And that was their mantle.
So they actually recreated the Earth's mantle in a tank.
Yeah.
Why gooey, though?
Good question. They used a gooey liquid because even though we think of the mantle as solid rock over ridiculously long periods, it actually behaves kind of like a very, very thick fluid. It's it's kind of like, imagine a glacier made of ice, right?
Yeah.
But it can actually flow. It carves out valleys and stuff.
Right, over a long time.
Exactly. It's solid, but on, a geological time scale, it's like a slow-moving fluid. So they use that goo to represent that.
Okay, that makes sense. So they've got their gooey mantle in a tank. How'd they recreate the actual drip part? With a giant pipette or something?
Not quite. They added a layer of this denser material on top of the goo. That was their lithosphere. Then, to get the drip going, they added a blob of even denser stuff. Imagine an extra dense chunk of the Earth's mantle just kind of sitting there.
And this is where it actually, dripped. They were able to recreate that super slow process.
That's right. They observed this model over time, and they could actually see this dense material sinking, stretching downwards, and eventually plops. It breaks off, just like they think is happening under the Konya Basin.
Wow. So their little model Earth gave them some solid evidence to support that dripping theory. That's really cool. But you mentioned earlier that this might not just be a Turkish thing. Are there other places where this, geological tug-of-war might be happening?
That's what's so exciting about this research. It's got scientists looking at other parts of the world with fresh eyes, the Andes, for example, and the Tibetan Plateau.
Because they have those high plateaus and depressions, too.
Exactly. They've got similar features to the Konya Basin. So it's got everyone wondering, what if those landscapes are also being shaped by these massive hidden drips? It's mind-blowing when you think about it. We tend to look at mountains and valleys as permanent fixtures.
Right, like they've always been there and always will be.
Exactly. But this research is saying maybe not. Maybe they're a lot more dynamic than we thought.
It's like the Earth is breathing. in super slow motion. Speaking of slow, you mentioned a really cool YouTube video about, I think it's called the pitch drop experiment.
Yeah.
What's that all about, and how does it tie into everything we've been talking about?
Yes. The pitch drop experiment, a classic. It's the perfect example of how even stuff we think of as solid can behave like fluids, given enough time, like the Earth's mantle. So this experiment, it's incredibly simple. They've got this hunk of pitch, which is like super thick tar, basically. And they're just waiting to see how long it takes for a single drop to fall.
And how long has it been? Decades, right?
It's been going for almost a century. And so far, they've only had like 9 drops fall.
9 drops in 100 years. That's wild.
It is. But it really drives home just how vast geological time really is. We think of pitch as solid, but over enough time, it drips. Just like we think of the Earth's mantle as solid. But over millions of years, it flows, just like that goo in our model Earth experiment.
So we've got dripping pitch, dripping rocks. It's all connected to this idea of deep time and how materials behave in ways we wouldn't expect over these immense timescales.
Absolutely. And it really makes you wonder, what else are we missing? What other hidden processes are out there, slowly but surely shaping our planet right under our noses? The Konya Basin might just be the tip of the iceberg.
It's amazing, isn't it? To think these slow, hidden processes are literally reshaping the planet. And we only know about them because of some really clever scientists and their experiments.
It really makes you appreciate the power of scientific curiosity. Somebody had to notice that basin was sinking in the first place and then figure out how to study it, even though it's happening so slowly and so far underground.
And now we have this whole new understanding of how dynamic the Earth's surface really is. It's not just about continents moving around.
Right.
We've got these hidden forces, these dripping rocks, shaping things over millions of years. It's incredible.
It really is. And this deep dive, it's really just the beginning. Which reminds me, I have one final thought for you.
Okay, hit me.
We've been talking about these downward drips, right? What if there are places where it's the opposite, where the Earth's mantle is like welling upwards, pushing the land up?
Oh, wow. Yeah, like a slow motion mountain building process.
Yeah.
That's fascinating. How would we even begin to look for something like that?
It's a great question. And it just goes to show there's still so much out there we don't know. The Earth is full of mysteries.
That's for sure. It really makes you look at everything differently. Well, this has been an incredible deep dive. We started with a sinking basin in Turkey, and somehow we ended up talking about the nature of time and the power of scientific curiosity. Thanks for coming on this journey with me, and until next time, keep exploring.